Good day. The topic of our study is interdisciplinary problems of mathematical content as a means of teaching programming to secondary school pupils. The authors are Bazurin, Chashechnikova, Karpenko, Pursky, and Palchuk. The relevance of the study is due to the following factors. The need of the labor market for IT professionals and higher education institutions for students who have programming skills, distance learning of students during quarantine, insufficient level of motivation of students to study programming. In our study, we relied on the research of the following scientists: Lo, Li, Yu, Shevchuk, Krivonos, and others. The aim of the research is to develop a classification of interdisciplinary problems with mathematical content and determine the impact of these problems on the formation of pupils' ability to develop algorithms and write them in the programming language. The research questions are, first, how much does the mathematical content of programming problems affect the level of formation of the ability to solve programming? Second, how different is the dynamics of the development of the ability to solve programming problems for pupils who use and do not use practice-oriented programming problems? These questions are important because they answer the questions of the effectiveness of practice-oriented interdisciplinary problems in the progress of learning of programming basics in secondary education. The main ways to solve these problems are to develop a system of practice-oriented problems and test their effectiveness through pedagogical experiment. Independent variables are the main stage of the research. The content of this task is traditional, and at the end of the stage, the pupil's ability to solve programming problems was diagnosed. The selection of pupils of control and experimental groups was carried out. Control and experimental groups were compared according to criterion chi². And the second stage in experimental group lessons were held with the use of practice-oriented programming problems 5 months. And the third stage, the diagnostics of the level of formation of skills to solve programming problems were carried out. Types of practice-oriented programming problems: interdisciplinary, professionally oriented, and socially oriented. The dependent variable is the level of pupils' ability to solve programming problems. We have improved the classification of interdisciplinary problems in programming by level of complexity. Please see on this slide. First, information and prescription interdisciplinary problems, learning material in mathematics and or programming as a basics or solving a programming is used. The second, reproductive interdisciplinary problems, problems to build semantic associations between the learned material in mathematics and programming. Third, research learned material problems that do not have a clear statement in the process of their solving. Pupils must determine either their condition or statement. Fourth, problematic learned material that are aimed at understanding hidden connection and relationships. The research were conducted of 3 stages: ascertaining stage, formative stage, and control stage. The results of ascertaining stage are shown on the slide. The results of control stage are shown on this slide. The second research question was how different is the dynamics of the development of ability to solve programming problems for people who are used and who do not use practice-oriented programming problems. To answer these questions, the result of ascertaining first stage and control third stage of the study were analyzed in detail and compared. The results were summarized in diagram on the slide. Conclusions. Motivation has a positive effect on the learning outcomes of high school programming. One of the ways to increase students' motivation to study programming is practice-oriented content of programming tasks. Practical-oriented tasks of the basis of programming for high school students should be a holistic system and be used in the process of studying all topics of the section of fundamentals of programming of the school course of programming science, computer science. As a result of the application of the system of practice-oriented problems on the basics of programming, students formed a higher level than students who solved programs for textbooks. As a result of the application of the system of practice-oriented tasks, a positive dynamics of growth of the level of ability to solve programming problems were relieved. Thanks for attention. Goodbye.